I thought it might be easier if I worked through a discounted cash flow NPV problem with you so you can actually see what's going on. So first of all, I'm going to work out what the net present value of the streams of cash flows are using the Excel formula. Now I'm on a Macintosh, so your version of Excel might be a little bit different, but what you need is the bit that inserts a function. Now there are a number of ways of doing that on Mac. An insert function is what I'm going to do, and then I can search for the one I want, which is NPV, and it'll select it, double click. It wants the interest rate. I've set this to 10%, and I'll explain why I'm using that rather than the 5% I talked about in class in a sec. And then I have to put in the range of values. So I will highlight those on the spreadsheet. Now for net present value, what you're looking at is the stream of cash flows, not the initial investment, because what you're trying to work out is what those stream of cash flows are worth today. So I have highlighted the 5 cash flows from the 5 years of operation, years 1 through 5, and they go into my formula, press return, and there's my answer. Similarly, if I want to check the other lot of cash flows where Camilla is drawing a salary, so she's taking some money out of the business, similar idea, use the NPV formula, select my interest rate, and by the way I could have made that a named variable, could have been a good thing to do. Select the range of cells that holds the cash flows, and I get my answer. Now, the important thing to note there is that the cash flows must be over equal periods. In this case, it's the years. So cash flow years 1, 2, 3, 4, 5. Okay, so Excel has given me the answers, but that probably doesn't help you to understand what's going on. So what I thought I would do is over on the right-hand side of the spreadsheet, I can actually show you the components that go into that NPV calculation that Excel has just done. So I'm doing that by showing you what the discount factor is. Now, if we have a look at the PowerPoint slides, we looked at compound growth, and we noticed that as the years go by, because you're getting interest on interest, then rather than increasing by a fixed amount each year, so instead of year 1 you add 10% and it goes to 1.1, year 2 you don't add another 10 and go to 1.2, because you're adding 10% on top of the 1.1 that you've already got rather than just 1. So actually you're getting 1.1 times 1.1, which is 1.21. And for year 3 you're getting 1.1 times 1.1 times 1.1, which is 1.33, and so on until you get to year 5, which is 1.1 multiplied together 5 times, or in mathematical terms to the power of 5. So if that's what your $1 is going to be worth in 5 years' time, if you get 10% interest every year, then it also follows that $1.61 in 5 years' time is worth $1 today, simply by dividing it by that multiple. So to know what $1 is worth at 10% rate of compound growth in 5 years' time, you multiply it by 1.1 to the power of 5. To find out what something is worth now, given a certain amount in 5 years' time at a rate of interest of 10%, you divide by 1.1 to the power of 5. So let's put those discount factors into the spreadsheet. Now the Excel function, let me use the function calculate, find to do that, for powers is simply called power, and what I want is a number. Now my number in this case is 1 plus my interest rate. Now, and I'm going to make that an absolute variable. And on the Mac, Command T does that for you. I haven't found the equivalent on Windows, I'm afraid. And it's to the power of the number of periods that you're calculating it over. So this is year 1. So if I copy that formula down and I look at what the contents of it are, this is 1.1, 1 plus the interest rate to the power of how many years it is. So 2, 3, 4, 5. Now if you look at those numbers, you'll see that they're exactly the same as the numbers that appear in the first column of this compound growth table. But what you're trying to do in this case is not work out how much a dollar is worth in 1 year's time or 2 years' time or 3 years' time. What you're trying to work out is what a dollar amount is worth today at an interest rate of, in this case, 10%. So instead of multiplying, you divide. So to work out the discounted cash flow for each of those years of cash flows, you simply divide it by the discount factor that applies for that period. So 1.1 for 1 year, 1.21 for 2 years, 1.33 for 3 years, 1.46 for 4 years, 1.61 for 5 years. So let's see what we get. Take the cash flow, divide it by the discount factor, and there's your answer. And if I copy that formula down, you get the discounted cash, the present value of each of these individual cash flows. So that is the present value of cash flow from year 1 in today's dollars. That's the present value of cash flow from year 2, year 3, from year 4, and from year 5. And if you add them all up, in fact I can copy this formula here because that's already a total. And just to verify that it is adding up the right amount. And you'll see the answer you get is the same as this net present value total here. So what net present value has done is it's done all these calculation steps for you and added up the result. So similarly, you can do the same thing for the other set of cash flows. Take the year 1 divided by the year 1 discount factor and so on. Add them all up. Let's just copy the total formula. And there you go. So that's net present value. Internal rate of return is a slightly different question. What the internal rate of return says, if I put in a certain amount at the beginning and I get cash flows over a period of time, what average annual rate of return does that represent? So for internal rate of return, you need an initial investment which will be a negative amount because that's money you're putting in rather than getting back. So let's see how that one works. I've got my formula builder up here. If I look up IRR, which is the formula for internal rate of return, it wants a set of values and it says you can put in a guess but you don't actually need to. So this one I have to highlight the initial investment as well as the yearly cash flows. And you'll see that gives me the internal rate of return. So what that is saying is that for your investment of $20,000, the cash flows that you get back over the next 5 years are actually worth an average annual return of 182%, which is pretty damn good and better than you can expect from anything in reality. Similarly, for the, in fact, for the other column, I can just copy it across. So you'll notice that formula just takes a stream of cash flows. It doesn't require you to put in an interest rate because the interest rate is the answer that you're trying to get, the internal rate of return. So hopefully that makes this process a little bit easier to understand.